If you were to ask Google when will Mount Vesuvius erupt, it would tell you in 38,000 years based on an analysis of its past eruptions. But you might want to check your calendar for that year because there's a new study out with a different prediction. The researchers found that if the volcano erupts like it did in 79 AD, it could happen much sooner than expected. Let's dive into this superheated science. We have to start this story with a disclaimer. A little over 1,000 years ago, Mount Vesuvius was just minding its own business being a dormant volcano in Italy until one day it decided to blow its top and destroy the Roman city of Pompeii. And we all know how great those movies are. And by all I mean I and maybe a few others. But aside from the death and destruction, this eruption was pretty great because it preserved the city in time. It's given us an amazing look at life in ancient Rome and provided scientists with a lot of data about the eruption itself. But it turns out you can't trust volcanoes even though they're kinda hot. Now thanks to a paper published in AGU Advances, we have another piece of data to add to the pile, which is really great if you like data and/or understanding what the future may hold. If you want to better understand the future of your investments, then you need to start with today's sponsor Public.com. Public is a commission-free investing platform built for the next generation. They offer access to stocks, ETFs, and now physical silver, all from the comfort of your phone. Investing is a great way to build wealth over time, but for a long time it's been restricted to the wealthy. Public wants to change that. They offer fractional shares so you don't need thousands to invest in top companies like Tesla or Shopify. You can also invest in precious metals like silver, all from the comfort of your phone. I've actually had my eye on Public for a while because their mission to democratize finance really aligns with our goal here at SCI Show, to make science more accessible to everyone. So, thanks again to Public for sponsoring this video. The paper focuses on pumice lapilli and ash deposits from Vesuvius's most famous eruption. These are the layers of material that were ejected during the Plinian eruption of 79 AD. It's named after Pliny the Younger, who happened to be observing the eruption from a distance while hanging out in coastal Italy. He sent a letter describing the event to his friend, historian Tacitus, writing that the eruption began in the morning with a sudden blast of air that threw clots of earth and pumice stones skyward. It must have looked like a huge crane lifting up rocks and soil to such a height that they disappeared from view. The eruption lasted for 2 days, he wrote, and produced an immense volume of pumice and ashes. And since then, scientists have been trying to figure out just how immense that volume was. In this study, researchers used X-ray technology to analyze core samples of the material. The cores were taken from sites around Naples, which is basically sitting on top of Vesuvius, and it's extremely well studied. For this reason, Naples is sometimes called the Earth's time capsule. The team wanted to see if there was a correlation between the grain size of the deposit and the distance from the volcano. Grain size in this case referring to the size of little pieces of pumice and ash. This kind of analysis has been done before, but not to this resolution, and certainly never in a big city where the material is mixed with other stuff humans like to put in the ground, like trash and building foundations. After analyzing several sites, the team noticed that there was a relationship between the grain size and the distance away from Vesuvius. This meant that finer grains were deposited further away from the volcano, and coarser grains were found closer to it. With this info, the researchers developed a model to help them understand the eruption dynamics and predict the impact of future eruptions. Specifically, they wanted to know the maximum distance the eruption cloud would reach and the volume of material ejected during the eruption. They also wanted to know the total volume of material likely to be involved in future eruptions of similar magnitude. In order to do all that, they needed to get a handle on something called the explosivity index, which tells you how explosive an eruption is going to be. Basically, the higher the number, the more explosive. To figure out the explosivity index, the team looked at the total volume of material ejected from the volcano and the duration of the eruption. The researchers found that Vesuvius had an explosivity index of 4, which means it ranks among the world's most explosive volcanoes, including Krakatoa and Mount St. Helens. That's important because Mount Vesuvius is not considered an active volcano. It hasn't erupted in almost 2,000 years. Since 1926, Italian authorities have categorized the volcano as quiescent, meaning it's calm and inactive, but this study suggests it might not be as dormant as we think. It could have a big eruption in our lifetimes. Now, no one knows for sure when the volcano will blow. There are just lots of estimates based on lots of data. In the past, scientists have tried to use statistical models to predict when Vesuvius might erupt again. Using past eruptions to inform future predictions is common practice. Researchers just take the history of the volcano and find trends. Then they project those trends forward and hope they didn't miss anything. This paper uses a different technique. Instead of looking at the frequency of past eruptions, the authors analyzed the results of the Plinian eruption of 79 AD. But the problem with this approach is that you need a lot of really specific data. The eruption left behind a lot of historical records and archaeological evidence, but we're still missing some parts of the picture. Like we don't know the exact volume of material that was ejected during the eruption. The researchers estimate that it was somewhere between 1 and 3 cubic kilometers, but that's a pretty big range. We also don't know the exact explosivity index of the eruption. The authors came up with an index of 4, but based on past studies, the true number could be anywhere from 3 to 6, so there's a range of possible volumes and a range of possible explosivity indexes, and if you do math, you'll know there's a whole bunch of possible outcomes when you multiply these numbers together. That's where the 38,000-year figure comes in. Scientists plugged in the lower end of each range into the model and got a number that's very far in the future. They also ran simulations using the upper ends of the ranges and got a number that's much closer, maybe within the next 1,000 years. And that's why this new paper matters. By using a new method and high-resolution data, the authors were able to narrow down those ranges. Their analysis suggests that a future eruption with the same explosivity index and volume would only deposit coarse grains within 16 kilometers of Vesuvius. Finer grains would be found within 24 kilometers of the volcano. Not only does this suggest that Vesuvius is more active than we thought, but it also means the area affected by future eruptions might be smaller than predicted, so people living in the red zone may have a bit more time to evacuate if the volcano shows any signs of stirring. What's more, this new method might be helpful for studying other volcanoes too. It might even be used to help predict the impacts of supervolcanoes like Yellowstone. For now, though, we can keep watching Pompeii and enjoying the occasional Gary Oldman movie. Thanks for watching this episode of SCI Show, and thanks again to Public for supporting this episode.